In this talk, we're going to be talking about configuration management best practices. This talk is all about breadth. So the slides have been uploaded to the conference app, so you can download them from there. There's a link at the end that may be relevant, but we're not going to take enough time on any one of these slides to really digest it. So it's trying to give a broad overview so that you can then go back and look up these individual topics after the fact. We've also got 40 slides for a 45-minute talk, so there's that. All right, we're going to start by talking about writing formulas. These are all recommendations on how to write formulas. Now, formulas, a quick point of terminology, a salt state or an SLS file is a collection of salt states. Salt states are the function calls, right? File.managed, package.installed, that sort of thing. So an SLS file collects a bunch of states. A formula is just a bunch of SLS files that have some common theme, right? They all do things to Apache, right? Install modules, config files, that sort of thing. But they're all related. And so a lot of the things that apply to formulas and the public formulas organization at the SaltStack formulas GitHub organization are good practices for your states in your company as well. The recommendations in there are good for team environments where you've got a bunch of people that are all working on the same files. So we're going to start with some basics. We're going to start with some style recommendations. And the very first one is use descriptive state IDs. It sounds kind of obvious, but that state ID, as long as you specify a name argument, which we'll circle back to, is just an arbitrary human-friendly identifier to be able to find that state along, in the giant dictionary that is a state tree. And so the more descriptive you can be, the most self-describing you can be, the better. They are, through the magic of YAML, we'll circle back to how magic YAML is, you can have a state ID, which is delimited by underscores, but that's just a style choice. I like it because it auto-completes in Vim. Some people like a string, with punctuation and space-delimited words, that sort of thing. It doesn't matter. Let's see. But if you do complex characters, make sure you quote it. There's also module.function notation. This is for those of you who have been around for a little while. If you've ever seen the syntax that you see on the right, it's a legacy syntax. If you ever see it in an example or something, open a bug, we'll get it updated. But the service.running, package.installed, it's the most consistent. You're going to see that everywhere else in Salt. So it's a good thing to use here. Okay, so specify the name parameter. The name parameter is the very first argument to all of the state functions. So a common thing to do here is, let's see, I should have set this up beforehand. Chrome's full screening behavior is less than ideal. Sorry about that. Okay, so if you go to the SaltStack docs, for example, I hope everybody here is already aware of watching out for what module type you're diving in on. So M for execution modules, S for state modules, and sometimes they're going to have identical names, but they're totally different module types. There might be some implied relationship there, but it's not direct. So if we did states.file and we went into file.managed, these are just regular old Python functions, and that's kind of important for reasons we'll circle back to. But if we jump down to file.managed, you can see it's just a Python function. And if you're not a Python person, it's still kind of a good habit to get into eyeballing these function signatures because it helps you dissect what that function is supposed to, what parameters it's supposed to take. And so the very first parameter there is name. And that's why all of the state functions have this name parameter. It's just a keyword argument that gets passed in. So it's a good idea to specify name. Technically, it's optional. If you don't specify it, it'll just use the ID. But the reason it's nice to specify name is that argument to state functions is almost always the value that's going to vary between operating systems or versions, that sort of thing. In the case of Apache, HTTPD is fine for CentOS, but that's not going to work on Ubuntu or Debian machines. And so So specifying that means that you don't have to go back through and update all of your requisites, you know, if you ever need to add support for a new platform. So just get in the habit of adding it, even though it's a little extra verbose. Write comments. Again, kind of obvious. YAML is really forgiving about indentation and vertical white space when it comes to comments. So, you know, format them in whatever is best for whatever it is you're writing. Just be careful that you don't accidentally try to comment a JINJA variable with a YAML comment, and we'll circle back to why that's important in a minute. But yeah, describe like you would with any piece of code for the people that come in after you and have to figure out what you were doing. You know, enable is true is implicit on Debian machines, and so why do we have this in here at all? Well, it's in there because of that one CentOS machine in the corner that we have to support. All right, so render pipes. If you're not familiar with these, there is an implicit render pipe, which is JINJA to YAML, right? That's just the default. Salt does not care, and this is a recurring topic in this presentation. Salt does not care what it is you use to generate the data structure that is a salt state. It just cares that you get at that data structure. It can be database queries, it can be whatever, but the default is JINJA to YAML. So if you don't specify, that's what you're using. But one of the things I like about render pipes is there's a very visual aspect to it, meaning whatever JINJA produces is then passed to YAML, and that's kind of implicit with this pipe syntax here. And what's noteworthy here is they are completely separate steps that know nothing about each other. JINJA knows nothing about YAML, YAML knows nothing about JINJA. You can't share variables between the two. Whatever JINJA produces has to be valid YAML, but that's on you, right? The JINJA template engine is not going to help you produce valid YAML. We've got some helpers in Salt to do that, of course, but they're separate, and they happen in completely separate stages, so keep that in mind. JINJA is not idempotent. And this is important because with JINJA, you can do anything, right? You can shell out, you can call execution modules, you can change the state of the system if you want to. It is as open-ended as that sounds. But if you do that, you completely bypass the idempotent nature of salt states, meaning that pre-check, does anything need to change, never happens. And so avoid changing the system with JINJA unless you really know what you're doing. And if you do, comment it heavily so that your coworkers know what you're up to as well. JINJA's best used to gather information from the local system, from external systems. We'll harp on this a bit more. For readability, it's a good idea to separate the JINJA logic from the states themselves. JINJA is a little syntax heavy, a little noisy, and so the better job you can do separating those, the more your coworkers will thank you. Contrast the left to the right, for example. When you put conditionals right there in a state, it becomes really hard to eyeball, you know, YAML indentation errors, for example. And it just muddies up the whole thing. So if you can do all of the logic elsewhere and then just use JINJA to look up variables of pre-computed values, it really helps with readability. In this case, we're just putting the conditional above the state. That's less ideal for a couple of reasons. Map files are a better way to go about that, and we'll get to that. But you know, even if you did have to do a big conditional like this, save it to a variable with the set operator. So as we talked about, inspect the local system using JINJA. Now, sky's the limit, right? You can fetch data from Pillar. You can invoke execution modules. You can shell out. You can call out to external services, you know, query databases, query web services, that sort of thing. Salt has modules to do all of that. And since the minions are doing the work, there's no load on Salt to add extra functionality to that execution module invocation, right? As long as the external service can handle the load from, you know, however many minions you happen to have, then great. So, you know, in this case, we're setting a variable SE Linux enabled, and we're shelling out to SE status and piping that through awk, and then comparing what awk produces to a string so that we end up with a Boolean, right? So that's a nice thing. So now we can just say if SE Linux enabled throughout the other state run, and that's just a small example of things that you can do. Filter by, we're going to circle back to in a big way when we talk about map files. There's also ways to merge dictionaries. Inspect grains, combine data, right? You're querying all of these services, the local system, external services, and you're producing data, and then you're probably going to want to combine that so that you can then do something with it. Maybe it's overriding defaults. Maybe it's cobbling together complete data from several independent sources, that sort of thing. And then format it. format the data in JINJA so that it's easy to loop over, so that the loop itself is syntactically simple, and the logic is outside of that. So on that point, light conditionals, light looping, right? If it gets too heavy, if you've got, nested conditionals where, you've got if statements and if statements and if statements, and you've got that kind of pyramid of doom growing, that's a code smell, right? That means that you've got an awful lot of logic in your states, and maybe there's a better place for that logic because, as we've talked about, JINJA is kind of hard to read. So if you have to do that, then separate the states again from the logic. So make the loop, make the conditional, put the state in the middle where it can reference values safely, that sort of thing. Again, sky's the limit. You can automatically generate state files. That's the whole purpose of JINJA. It's a state file generator, right? And so you can use loops and that sort of thing. And if you do that, just remember to keep every state ID unique. Salt is building up a giant dictionary, and so every key in that dictionary has to be unique. It's just a data structure. All right, move complex logic into Python, right? It's a lot easier to write Python than it is to write JINJA. And JINJA is a logic-light templating language by design. It does not have a lot of constructs you would need to, say, put together a set of unique values, for example. They avoided that on purpose. So honor that decision and move things into Python. And there's a lot of good ways to do that in Salt. You can make custom execution modules. If you haven't done this, I would invite you to please do it. It is really as simple as making a /serve/salt/_modules directory, put a Python module in there that returns something that is JSON serializable. It can do whatever it is you can do in Python. It just needs to return something that is JSON serializable, and then run sync modules. And it goes out to all of your minions, and you're done, right? You can write a custom execution module in under a minute after you've done it once or twice. They are dead simple to write, and it's a great way to move logic to where it needs to be. You can also lean on the Python renderer, and we'll circle back to what that looks like in just a moment. You can also mix and match, if you would like, using this execution module here, SLSutil renderer. So you can call one renderer from inside of an SLS file, and we'll circle back to that as well. So JINJA macros come up frequently. JINJA macros are often confused with function calls. They're not, right? You're still in JINJA. It's still logic light. They're mini templates. So use them as though they're mini templates, right? If you've got some block in your SLS file that you're writing over and over and over, and it just has a few points that vary between invocations, make a macro. It'll save you some time. But that's a good use. Just don't, make a macro that is trying to, build up a unique list of something, right? That's the kind of common pattern. Let's see. Map files present a single location that you can reuse something. That something is data. It's logic. It's looking up a bunch of values, combining them, that sort of thing. Map files are completely open-ended. They're a pattern that kind of grew out of salt formulas. And what they do is they give you that central place. There's one place that you go to look for this, and you can reuse that across multiple SLS files. This is really important in Pillar, which is something we're going to circle back to. You can use map files in Pillar. You should use map files in Pillar. Pillar is just SLS files, same as Salt, only the thing that it produces is not as structured. So if you need to do something like fetch something from an external system and combine that with some defaults, right? Don't do that in every SLS file. Do it in one SLS file and then include that. So there's a syntax for this, which you may have seen if you're in the formulas organization that looks like this over here on the left. And it uses JINJA imports to pull that map file in. You've got to pass this with context, which is important. So that's what you've likely seen. Now, this SLSutil renderer function that we've mentioned before, it's a new addition in Salt, a semi-new addition, but it's been in for a couple of releases, so it's safe to use now. It's just a much better system in that you can mix and match. So you can write a map file in Python, you can import it in JINJA. You can write a map file in JINJA, you can import it in Python. So it's just a better way to go. There's an open pull request right now that adds salt:// support to those URLs to kind of round out the addition. But if you're on a pre-Oxygen release, it's easy to do yourself with just a CP cache file, right? That just grabs a file from the master and caches it locally on the minion. Let's see. So yeah, so with map files, the whole point is combining data, right? And so that data can and should come from multiple places. You've probably got, sane defaults. You've probably got overrides specific to, various systems. All of the, Ubuntu systems are going to be configured the same, except for that one legacy system in the corner, that, snowflake system that you can't get rid of for whatever reason. And so you want one-off overrides for that one, or that sort of thing. So map files are useful for all of that. There's two functions in the SLSutil module, merge and update, that allow you to combine dictionaries in an intelligent way without having to do a lot of fuss yourself. They can also be used to filter data. So say you've got this lookup table of all possible values for all possible systems, right? It's nice and lightweight. You can ship it along with your states. It's easy to reference, that sort of thing. But you want to drill down on that data structure for a particular system. This state file happens to be executing on a CentOS box at the moment, and so you want to filter out that CentOS information. And so the way you go about it is you've got this dictionary, or sorry, for this example, we're going by minion grain. So you've got this dictionary. It's got an application configured for foo and an application configured for bar, and you've got a grain that you can use to look that value up in the dictionary. That's all this is doing. It's just looking up a value in the dictionary, so you get a subset of that dictionary that you can then easily reuse. But there's also patterns around this with the grains filter by and the match filter by modules to do this a little bit more easily. So let's take a look at those. So you can filter by grains. This is just calling a function. It's doing essentially the same thing we just saw on the previous slide, but with some extras, and the syntax is a little nicer. So this is taking some dictionary that's keyed by grain values, and it doesn't matter what the grain value is. You can choose one arbitrarily. It's just a keyword argument to this function call. By default, it's the OS family grain. That's one of the common ones to filter on. And so this is nice for a few reasons. One is there's one file you can look in to see all of the values that are going to vary between your infrastructure, right? It's all right there. If you need to add support for a new OS, you just copy and paste a block and you swap out the values, and you're done. And then yeah, this filter by just says, if you're on a Red Hat system, grab the subset of the dictionary so that we can then reuse that from there on out. It also allows overriding by pillar values. All right. There's also a lesser-known one, which is in the match module. The match module is a module that exposes Salt's internal matcher. So when you run salt star test.ping, that star gets run through Salt's matcher code. Well, that matcher code is exposed, like a lot of Salt internals, as an execution module. So you can just play around with the match module and see what matches what if you'd like. So in this case, what we're doing is we're drilling down on a data structure using that matching logic. So if your host name starts with web, if your host name starts with DB, then this array of values applies to you, or this one does. And this is arbitrary, right? It doesn't need to be arrays. It can be whatever. Any kind of data structure that you want to drill down on can be in here. And then you just have to expose that filtered data to pillar by outputting it in a JSON as a JINJA variable. I'm piping it through the JSON filter here so that it preserves quoting. Whenever you've got a data structure in JINJA that you need to pass from pillar down to your minions, it's a good idea to just round trip that through the JSON JINJA filter there, because then you don't have to worry about any of YAML's kind of oddities where it will say automatically cast the string on to a Boolean, or do crazy things with date times, that sort of thing. This keeps the data structure simple and bulletproof. You can also search. There's another function in there which is basically the inverse of filter by, which allows you to filter on the data just from a different direction. So if you want to put various matches in there and then have the other data points pulled out in the other direction, it's just a different way to organize your map file. But once again, it's useful as that single source of truth. And when you do this in Pillar, and this is a good pattern in Pillar, when you do this in Pillar, all of this JINJA logic happens on the master. So what gets shipped down to the minions is just the subset of that data that applies to that particular minion and that particular minion. So it's safe to use in Pillar. Let's see. So we've already talked about how you can use the SLSutil renderer function to write a map file in any language, and that's what, or in any renderer, and that's what this looks like, right? So the Pi renderer has a function in it that returns something, right? And that something's going to be the state, the contents of the state. And so this is a good way to mix and match, right? If you wanted to do something crazy in Python and import that into JINJA, it would just look like this, right? You do the grains filter by exactly as you did before, but or whatever else you needed to do. But now you're doing it in Python, and so you have access to all of that. Yeah, we're a little short on time, so there'll be questions at the end, but yeah, go ahead if it's short. Yeah, the question is it possible to filter by non-root level keys? And the answer is yeah. Usually the pattern for that is you just have nested calls. So inside of the inner dictionary, you filter by again. Good question. So, all right. In order to author states for reuse, it's a good idea that each SLS file should do one thing and should do it well, right? The less an individual SLS file does by itself, the more you can use it in other contexts. So you can say, you can call it from state.sls. You can include it in a high state run. You can call it from orchestrate. You can call it from the reactor or that sort of thing. And so the less it does, the better for reuse. Let's see. And yeah, and that's reuse in different contexts. And we're going to circle back to this when we talk about orchestrate. And so if you write an SLS file to be self-contained, right? If that SLS file, needs to depend on something else. So for example, you've got an SLS file that puts an Apache configuration file into place, right? But once that's edited, you want it to restart the Apache service. Use an include to pull in the other state that manages the Apache service, and then use one of the requisite ins. The requisite ins, if you're not familiar with them, a good mnemonic for them is they're the inverse of a requisite. They reach in to another state and put a requisite for themselves in that other state, right? So you can write an SLS file that only manages an Apache config, but also happens to restart the Apache service when that changes using the watch in requisite. And that's a wonderful pattern for reuse. So includes, don't shy away from requisites and includes. Requisites tend to be a little verbose, and so a lot of people avoid them in favor of the top-down execution. But requisites are a really powerful way to definitively say, these are my dependencies, right? I need this, or I'm going to do this to this other thing. And so even though they're a little bit verbose to write the first time, once they're in, you're done, right? You don't have to go back in and fiddle with ordering after the fact. So, and again, keep complex logic out of states. Use the Pi renderer if you want. If you wanted to use the Pi renderer, it looks like this. So you can see I'm just doing just a regular file managed here. There's the name argument, there's the source argument. So file.managed is a list, right? If you're familiar with YAML, the kind of data structures that YAML produces, this is old news, but YAML's strength and weakness is that it doesn't look like a data structure when you write it out, even though it is one. And so keep in mind, Salt is expecting this to be a list of single key value dictionaries. And so that's what we're looking at. Again, custom execution modules are so easy to write. There's often not a good use case for this. Let's see, organization, keep your file directories shallow. Group related SLS files together, fairly obvious stuff. There's a function in Salt called cp.listStates. So you can do a salt star cp.listStates, and that'll query the salt master for all of the state files that live on the master that are available to that minion, and it'll produce a tree like this. So that's a nice thing to run, to just eyeball the tree to see how deep it is, how complex it is across your whole state tree. All right, let's talk about testing states. We'll be brief. 20 minutes, yeah, we're good. So when you're testing states, pay attention to the fact that you are building up a data structure. This is a running theme in Salt states, and it's not totally obvious, especially for newcomers, especially for people that are coming into the docs fresh. If you haven't had somebody tell you that Salt states are data structures, it's not always obvious, right? So here's the kind of step-by-step life cycle of kicking off a state run. You run salt star, state.sls, and then some SLS file, right? The minion gets that publish. It sees that it's being asked to run state.sls. It says, okay, do I have a copy of this SLS file? In this case, it does not, so it'll request that SLS file from the master via Salt's file server. It'll download that SLS file and parse it using JINJA. Whatever JINJA produces must be valid YAML, as we've talked about, and then that gets run through the YAML parser. Whatever YAML produces at that point must be a valid high-state data structure. That's the name of the data structure that we use in Salt. It's a documented data structure. If you search the Salt docs for high state, you'll see all of the constituent parts broken out in the documentation. So it's a specific data structure that Salt's state compiler is expecting. So YAML produces that. That is handed off to Salt's state compiler. Salt's state compiler takes that. It takes the high state, turns it into what's called low state, which is just a little bit more machine friendly. And then it starts looping over the low state. Now, we'll circle back to this in just a moment, but one of the important takeaways here is at this point, there's not a lot of ordering that's been done. Some implicit ordering has been done if you're using, say, the default YAML to JINJA render pipe. It reads that file in source order and keeps a little counter as it reads it and that sort of thing. So there's been a little bit of ordering, but not a lot. None of the requisites have been evaluated yet because requisites are evaluated at runtime. This is important. So it starts going through this list. It gets to, package.install, to install Apache. It gets to service.running to start Apache. But it sees that service.running has a requisite for the Apache configuration file. We want to put the configuration file in place first before we start the service, right? And so it hits that requisite and it pauses and it looks that requisite up. It finds that requisite. It runs that requisite. And then once that's satisfied, it circles back and it says, okay, now I can continue on. I can start the service. And so very sequentially, I want to dispel some of the magic around Salt's state system in that it's just executing functions one after the other. The functions don't know anything about each other. There's no concept of, entities or resources, that sort of thing. It's just functions getting called with arguments, oftentimes, just using primitives. And so it just goes through and does that. And while it's doing that, whenever a state function is executed, the return from that state function is added to a dictionary that we call the running dictionary. And that is what you see at the end of the run. When you get the results back from a state run, you see just a pretty version of what is the running dictionary. So all of these results are put into the running dictionary. Salt uses that running dictionary to decide whether or not a function has been run already. If there's a requisite, it looks that up in the running dictionary. Do we already have a result for this kind of a thing? In the case of the on changes or the on fail requisites, it'll look up in that running dictionary to see if the changes dictionary is empty or if the result field is true or false. And so I would invite you to kick off a state run, state.sls something, and then output that as JSON, right? Because you can see this data structure represented in JSON, and again, that just kind of helps dispel some of the magic. One of the important things to note about the running dictionary is, well, actually, we'll circle back to this, is the running dictionary is the final word on which states ran in what order, which is nice. All right, so now that we've covered that, keep in mind, when you're testing Salt states, which layer are you testing, right? Are you trying to fish out JINJA or YAML syntax errors, right? If so, you're going to look for those in a particular place, right? Those are going to be formatted in a particular way. Once you've got the syntax for JINJA and YAML done, is the data structure that YAML has produced, is that a valid high-state data structure, right? So in that case, you'd be seeing errors from Salt's state compiler rather than from JINJA or YAML. If all of that's done, right, are you testing ordering, right? I've got implicit ordering, with top-down execution, plus I've got a few requisites sprinkled throughout and, maybe some include statements. Is this executing in the order that I wanted and expected, right? So you would debug that in a very different way by, we'll circle back to the command that you would run to do that. Or are you trying to verify the final result? So Salt's state run says that it finished. How do I verify that it did what I expected it to do? How do I verify that it was successful? Right. So, here's the running dictionary in JSON format. So I've omitted a few things because the slide is not big enough, but you can see the changes dictionary is non-empty. Run num is just a counter of what order things ran in, starting from 0 and incrementing from there. Result is true, says whether or not the state was successful or not. And that's it, right? Those are those are the values in that are used programmatically by other states to say, did this thing that I depend on succeed or fail or produce changes? All right, so there's a lot more to say about testing salt states, and I would invite you to attend a presentation tomorrow by Daniel Wallace. He works at SaltStack, which is going over a new addition to Salt, which is we're bringing in Test Kitchen, and we're using that as our official way going forward for testing SLS files. We've talked to the original author, and they've agreed to make that an official part of Salt. So that's going to be a big thing going forward. So don't miss this presentation tomorrow at 1:45. All right, let's segue a bit and let's talk about some cool SLS tricks, and then we'll talk about Orchestrate, and that'll be the presentation. About 14 minutes to go. So let's talk about preconditions. As long as you've kind of followed some of the advice up till now, complex SLS files are really powerful things. And so focus on readability, but don't worry so much about complexity, right? If you're trying to do something complex, write a complex SLS file, just keep it readable. So preconditions are part of that, right? So say you've got an SLS file that depends on certain pillar values being present, or certain pillar values being certain data types. There's a function called test.checkPillar, which will allow you to say, make sure the foo value is present in pillar, and if it's not, fail this state. And because the state's going to fail, you might want to pass the fail hard true option to that. It's a global argument, excuse me, if you're not familiar, which will halt a state run if any state, if that state with the fail hard true fails. You can also say, make sure that foo is an integer, or make sure it's a Boolean, that sort of thing. So you can get pretty granular. And that's a nice way to sanity check that pillar values are available. If you do that, just remember this is after this data structure has been handed to Salt State Compiler. So JINJA and YAML have both run at this point. You can also throw tracebacks like this. Salt.test.exception, right? And you just put it in a do notation in Salt. It's an optional addition to JINJA, but we've enabled it by default in Salt for a while now. And so that lets you throw an exception at an arbitrary point. So maybe you're checking, if something on the system looks like this, else throw an exception kind of a thing. So that's a nice way to bail out of a state early. But again, remember that render pipe's order, right? The JINJA is going to run first, then the YAML, then the state compiler, and so make sure that you know that you're checking things where and when they need to be checked. Let's talk about debugging. So there's a few ways to do this. One is just good old print lining, right? Adding a print statement somewhere in your code, and the Salt equivalent of print lining looks like this. So there's a state in the test module, the test state module, I should say, called configurable test state. It allows you to just make a test state that returns whatever you want it to return for testing purposes. But it's really nice for print lining because you can put whatever you want in the comment field. And if you do this YAML multi-line string syntax, then you can put any kind of data structure in here. Again, useful to pipe through the JSON filter just to preserve quoting and data types and that sort of thing. But that's a nice way to just print line something real quickly. There's also a recent addition to Salt that allows you to tie into Salt's logging system. So you can do salt.log and then the log level, so info, error, debug, that sort of thing, and the value, the variable. So if you're looping through something, you can see the value, and that just shows up in the Salt minion log, or if you're running it via Salt call on the CLI, which is a nice way to develop states, in my opinion, just locally using Salt call. You'll see it right there on the CLI. All right. Orchestrate. So Orchestrate, we're going to talk about Orchestrate because it is an often overlooked part of Salt. It's been in Salt for a good long while, but it's not a common thing to realize that Orchestrate can be used for as much as it can. It's often seen as just a way to, say, send executions to minions, for example. But what it is it's a master-side state run. That's it. And that's as open-ended as it sounds. Sometimes it takes a second to wrap your head around that, but it is just a regular state run that happens to be running on the master, right? That means that you can take an SLS file that was written to run on a minion and run it on your master, right? If you need to produce that same result on your master for whatever reason, say you're adding users or You're just setting up your master. You're programmatically setting up your master. You can take that SLS file, run it on your master using salt run state.org, and the same SLS file will run because it uses all of the same state machinery. It's running in a different context, and there's some things to talk about that, which we'll get to, but it's the exact same state system. You've got access to all of the same requisites, that sort of thing. But it's running on the master, which means you've got access to extra stuff too, right? You've got access to all of the cache data on the master. You've got access to being able to send executions to minions and wait for that, and then send executions to other minions, right? And that's where the power comes in, is you've got that kind of central point of view. Use map files and orchestrate. Again, not something that's seen very often, but for the same reasons, map files are a good idea in Pillar and in state files, they're a good idea in orchestrate, and they follow the exact same pattern for all of the reasons we've already covered. If you guys have ever come across the problem of wanting to include a Pillar value from another Pillar SLS file, map files are a great way to sidestep that, incidentally. You put the values that you want to reuse in a map file, and you pull that into multiple Pillar files, and done, right? It completely sidesteps that problem, and it's a good pattern just for centralizing that lookup data. Let's see, yeah. All right, so this is kind of an interesting secret that not very many people know about. There's a lot of code that is shared between the master and the minion daemons. And so the master can pick up an ID, just like the minion can. It doesn't have a default setting, and it might not even be documented. But it just picks up an ID, just like a minion would. If you don't specify it, it uses the same logic that the minion does and picks up the fully qualified domain name of the system. But if you edit the master config, and you put in ID : and then you name your master something, it just works. So that would allow you to say, send certain Pillar values to your master and certain Pillar values to your minions again. And so in this example, we're running state.org, salt run state.org, ID from Pillar, and we're running it on the master. And in that, we're running that same state that we were looking at earlier. In the comment, we get back the ID that has been assigned to that master. And if we run the exact same file on a minion, once again, we get that result, but for that minion's data. And so that's a nice way to say, write an SLS file that is intended to run on both a master and a minion by assigning Pillar values to both of those systems. If you're in the habit of running a minion daemon on your master, that's a very common pattern, and there's nothing wrong with doing that. But if you'd rather not do that for whatever reason, this is a fine pattern for not having to do that. Let's see. There is a wealth of information available on the master, right? You've got access to all of the cached values from all of your minions. That's cached grains, that's cached Pillar, that's cached mine, that sort of thing. And so you don't need to round trip a query through your infrastructure that has all of the overhead that entails to find something out if from an orchestrate file, if you can just check that local cache. So for example, in this example here, we're producing a list of minion IDs by calling out to a runner, cache.grains, the cache.grains runner. And the nice thing about the cache.grains runner is it can make use of Salt's matching logic to filter down on that data structure. So you can say, I only want all of the minions that match this grain, right, or this target. And then a nice pattern after that is, so this is just a Python value. Quick side note, JINJA and Python are not the same, but JINJA was written by Python people, and if you have a Python data type in memory, you can chain off of that and access all of the methods on that data type. So string methods, array methods, that sort of thing. You can just do dot, whatever. So in this case, we get back a dictionary of all of the grains, but we just want the minion IDs, right? So we're going to do dot keys on that dictionary, and so poof, now we've got an array of minion IDs that have been filtered by that target that now we can do something crazy with in orchestrate. So in this case, this is kind of contrived, but we're just going to loop over that. So for minion ID and minion IDs, we're going to do serial execution, make a unique state ID here, and we're going to do salt.state on that target, and we're going to hard code an SLS file for reasons. And so that'll just go through one after the other and serially execute state run on your minions. You can do that with Salt's batch system too. This is just an example, but that's an idea of what you could do with, say, generating that on the master and orchestrate. There's another common pattern by, you can call that to Salt Cloud as well. So say you wanted to query Salt Cloud for all of the IPs, of your currently spun up VMs, and maybe use SSH or do something to that list of IPs. So anything you can query and pull into a variable is something that you can then make use of programmatically and orchestrate. Let's see. Oh, you can also generate pillar fresh. So you can use the cached values that were sent to a minion, the cached pillar values that were sent to a minion. And that's nice because they're already on disk and they're already cached. But if you want to generate the most fresh, most up-to-date copy of pillar that would be sent to that minion, you can do that using the pillar module. There's also one other runner that's worth mentioning here. It's the queue runner. Again, often overlooked. But what it does is it just maintains a queue. You can pop things onto, or you can push things onto the queue. You can pop things off of it, and so that allows you to say, just keep a list of things to do, work to do, or whatever you would use a queue for. And it has a variety of backends. It's yet another one of Salt's pluggable interfaces, so you can just say write things to a SQLite database. So you can process requests coming in and add that to SQLite, and then batch them and process them later on at night or something like that. It's built into Salt and it's there, so it's easy to use and easy to use from Orchestrate. There's also what are called verification states. These are, again, not highly known, but what they do, they're states or execution modules that will verify or they'll check a condition without changing the underlying system. They're scattered throughout Salt. It would be a nice thing to, in the docs to take a list of those that are all identified as verification-specific states. But here's an example, right? Network.connect. Network.connect tries to connect to a port on some machine. You can see why this would be useful from Orchestrate, right? From the point of view of the master. If you kick off something on a minion, you start a service or that sort of thing, now you can try and connect to that service by connecting to that port until it comes up, right? And there's retry intervals. This is specific to Salt's state system, this retry. So you can put that on any state in Salt. It's not specific to Network Connect. And so, yeah, it's a nice way to just continually pull something until it either times out or comes up, and you can move on successfully. There's another one called, this is a state module, called HTTP wait for successful query. And that does the exact same thing. It's got similar semantics, except it makes an HTTP request and examines the response headers and the response body optionally if you want. So you could say, spin up Apache and make sure that it actually spun up the right vhost instead of the default welcome to Apache, that page. Nice thing to do from Orchestrate. And again, these are just regular old state modules or execution modules that are available to Salt. So it's useful to do this from Orchestrate for obvious reasons. The master is central. But there's no reason that you couldn't also have a minion check on another minion, that happens to be adjacent to it. Maybe something specific to inside of a data center or something like that using these modules. So I'll call them verification states. All right, last thing to talk about. I thought it would be useful to see what a complex multi-host Orchestrate with preconditions and error checking and that sort of thing looks like. So I put together this gist file a little while back for the mailing list. But the short version of what it does is it gets a dynamic list of hosts. It will perform a few pre-checks, validations. It'll loop over each host. It'll fetch information about that host that it's currently looping over. It'll remove that host from the HA proxy pool. It'll stop the service on that host. It'll wait for all of the users to drain off of that host. Then it'll upgrade the app, the web app or whatever it is we happen to be doing. It'll upgrade that app if it needs to be upgraded. If it doesn't need to be upgraded, then it doesn't do anything. And then it'll bring that service back up after the app is upgraded. It will re-add it to the pool. Before it re-adds it to the pool, it'll check to see if the service actually did come up and came up in the expected way. Then it re-adds it to the pool. And so that's an awful lot of stuff. And so I thought it would be a fun way to go out. It looks like this in the gist file. And there's nothing groundbreaking in here, but it just kind of cobbles together a bunch of ideas to do something kind of complex. And so that's it. We've got a few minutes left for questions. And also, I'll be available afterward for questions.
I was looking at probably the configuration
For testing states?
Yeah, for like say I want to test my own stuff with the exact same framework.
Okay. The question was, is it possible to pull in Salt's unit and integration test framework for testing states? And the short answer is no. The thing that the presentation tomorrow is on is the answer to that question. So that'll be the way of testing SLS files going forward.
We have in our organization some requests of getting, like they run a command on a whole bunch of minions, and then they want the results of that put on another minion.
Mm-hmm.
Do you have a recommendation for the best, like the queue sounds like a good idea?
Yeah.
Like how to manage that?
I could see that. The question is, how do you get the results from an execution on one group of minions onto another minion? Orchestrate is a nice place to do that, maybe the reactor as well. Some central place where you can aggregate that data, either synchronously waiting for an orchestrate to run or asynchronously gathering that data via the reactor. And then, once putting it in the queue, using the queue module to store that in a SQLite database would be a fine way to go. Or if you just wanted to write to that minion incrementally, I'd say just follow it up with an execution. It could be as simple as a command.run, echo, append to a file kind of a thing. As long as you pass the data along structured, so pipe it through the JSON filter, so you're writing JSON, something that's not going to get messed up in translation would be a good pattern for that.
So if there's a state foo that fails, I think there's an on fail that you could have a var follow up. Is there a way in var to turn that fail back into a success?
Good question. The question is, there's an on-fail requisite. If you're handling a failure in another state with an on-fail requisite, is there a way to turn that failure into a success? And the answer is no. There's an open feature request in Salt to add a flag for that, which makes total sense, right? If you handled the error, it shouldn't be an error. All right, we are out of time, but I'll be available in the hall if anybody has any additional questions. Thank you for coming.